Okay, first we look at the single bond of molecule. As we can see, this is the model of ethane. All the bonds in ethane are sigma bonds. The CC bond is formed from the overlap of an sp3. Rotation can occur because the heaviest electron density in the sigma bond exists along an imaginary line between two carbon nuclei, and rotation does not change this electron distribution. Rotation can occur around the central CC bond, allowing two CH3 group of ethane to rotate, allowing the hydrogen on one carbon to adopt different orientation. These arrangements are called conformation. These are two different conformations called eclipse and staggered conformation that can be represented by Newman projection. In the beginning, ethane will be in eclipse conformation with a 0-degree dihedral angle where CH bonds are aligned. If you rotate 60 degrees, ethane will transform its conformation to staggered conformation, which is more stable and lower in energy. Next, I will rotate the model of ethane. One of the CC bonds result from the end-on overlap of an sp2 hybrid orbital, and another second CC bond result from the side-by-side overlap of two p orbitals on each carbon. Rotation around a double bond is restricted because the pi bond prevents rotation because of the electron overlap both above and below the plane of the atom. It can only occur if bond first break, but of course it requires a lot of energy. Okay, last we move to the ethyne model. Ethyne model cannot be rotated because these two pi bonds formed by the side-by-side overlap of two sets of 2p orbital with carbon, and the pi bonds are created by the side-to-side overlap of atomic p orbital. Any rotation around the sigma bond results in the destruction of all of the pi bonds, so the ethyne cannot be rotated.
Now, we move to the next question, which I need to superimpose molecules of alkene and identify if they are two different of molecule or otherwise. This is two molecular model of chloroethene which have one chlorine and substituent that attach on the first carbon. Now we will throw them freely and pick up both model. Let's see if they superimpose on each other. Yes, they superimpose approximately each other. Superimpose means it's like exactly the same as its mirror image. Therefore, both models of chloroethene are the same molecules. It is impossible to form isomer, hence it does not exhibit geometrical isomerism. Next, what if we have two models of molecules that have two chlorine atoms attached in the same carbon, which is 1,1-dichloroethene? We throw both molecules freely and see that if we can superimpose both models, the results show that both molecules are superimposable each other. Do you think that they are two different molecules? No, these two models of 1,1-dichloroethene are the same molecule because 1,1-dichloroethene have chlorine atoms on the same carbon. Hence, it does not have any change of transform. Thus, it does not exhibit geometrical isomerism. Last, two molecular model of 1,2-dichloroethene. First, throw them freely and see if they superimpose approximately each other. As a result, they are both not superimpose each other. Do you think that they are two different molecules? Yes, they are two different molecules, and the naming for both molecules are also different. Because double bond stereoisomerism is 1,2-dichloroethene. This 1,2-dichloroethene is a molecule with chlorine substituent on the same side, while trans 1,2-dichloroethene is a molecule with chlorine substituent on opposite side. Hence, there is no way of superimposing the structure on each other through bond rotation because of the central double bond of C double bond C. Therefore, rotation is not allowed on double bond.
For question 3, we have bromochlorofluoromethane. For this question, we want to see if a mirror image can be produced or not if second model of bromochlorofluoromethane rotated. Both shows the superimposed molecular models of bromochlorofluoromethane. Both carbon atoms carry 4 different substituents which are bromine, chlorine, fluorine and hydrogen. When the second model rotated, we can see that the location of fluorine and chlorine are not same. It is because this molecule is a chiral and it can form enantiomers. In conclusion, the mirror image cannot be produced after rotate the second model because these two molecules are enantiomers. These are chiral molecules because these molecules have a chiral center, are also known as asymmetrical carbon that has 4 different groups or substituents. Whenever you have a chiral molecules, those 2 molecules are known as enantiomers. Enantiomers are non-superimposable mirror images of each other. For the next question, we want to see if there is a second different molecule for the molecular formula of bromochlorofluoromethane or not if we exchange any 2 atoms of one of the models. Next, we change the position of bromine atoms and chlorine atom. Then we throw freely both models and pick them up. Next, we observe that these 2 models are superimposed or not after we throw them. Both models cannot be superimposed because the position of bromine and chlorine atom in both models are not same. From this procedure, there is no second different molecule of bromochlorofluoromethane because this molecule can generate 3 possible stereoisomers. These molecules have same molecular formula and bonding arrangement, but different arrangements of atom.